recording. Okay, so today is I hope a big day because we're going to introduce the ability to do lookups, including nested slash qualified lookups. And now I remember where we were. We were discussing copy pasting the dynamic scope implementation of that famous guy into the project in order to implement the log levels without using global mutation. My
Oh
opinion
yeah,
is
right.
we should not do that right now. We should add to the bucket list of issues that I haven't written yet. And then we should actually just choose whatever API we decided that I already forgot. We're gonna do what? We're
The quick
gonna
and dirty way is just use a mutable cell.
no. I mean that's not the quick and dirty. The quick and dirty I think it's to let the logs happen and just ignore them during implementation.
Oh yeah, that's the janky way actually.
Yeah, that's the real dirty way of doing it. Yeah, so I think we can start with that.
Okay, so we're going to ignore the logs. All
Well, not
right.
all logs, but those ones specifically.
Yeah, the ones where, okay, we're doing a nested lookup and we're trying to find the scope to start the lookup from by looking at the parents, right?
Yeah.
Obviously, some of those lookups will fail and they may have logs that we would need to suppress, but for now we're just going to let them happen and ignore them.
Yeah, exactly.
Okay, sounds like a plan. Those two to-dos, we haven't addressed them yet, right? Or
Sorry.
have we?
What's the repeat?
These two to-dos for actually doing the qualified, like the nested lookup,
No, no, no,
did
no,
we
no.
address them?
No, we didn't. We didn't address them. Okay, I remember. It's because 375 the name is empty, and that's fucked up.
The name is empty.
No, no, not the name. The first member of the tuple. That is empty, which means that we're not handling when you are qualifying the thing. And that's what this to do is kind of misplaced because it should be
Oh,
above
right.
the
This,
375.
this. Okay, yeah, no, this is about the pattern, not necessarily the code. Okay.
Yeah. And then this one, the 384, is something completely different. I don't remember exactly. I just remember that 390 and 391 are a hack to make it work for now. But I don't really remember the right way. You were the one saying there was a right way, and there was, but I just don't remember what it was.
Okay, let's see. Where is the entry point?
Of
Here,
what?
right? Of the lookup module.
Yeah, so we have a lookup mod sig that should not be exported in the signature in the future. I actually have I have a little bit of anxiety on how we're going to divide and conquer this later because a lot of this is mutually recursive, using types that are coming from the outside, they're not qualified, and things like that. So I don't know how we're going to divide this later to make this file not be like gigantic. But for now, this is how it works.
Okay, so lookup mod sig, and then we have specific lookup functions for specific things. We have one for predicates, one for modules, and one for signature, right?
Yeah, exactly.
Okay.
Wait, but there's a problem.
Hmm.
There is a problemo. Man, I thought, here's the thing. I thought that we would not use options anymore.
We will actually, because like when we actually start doing the
No, but we didn't want to do the nested, like we didn't want to pattern match on the option, remember? That was one of the things.
no, yes, but we'll have to do it because we have the, well, actually, not really. There's this accumulator here, right? Which is the module currently being compiled, essentially.
I remember that, yeah.
Yeah, so what we need to
We
do,
should rename that, but okay, we can do that later.
yeah, so what we need to do is, okay, we have to do the lookup twice, potentially, because we need to look first at the accumulator,
And
and then we need to look
then
at the surrounding scope,
and
like
then we do the
outward.
exit. If both of them fails, then we do it.
But we may have a way to avoid that if we make the parent of the accumulator be the surrounding scope already, right? Because then our nested rule will already apply and we don't have to do anything here on the left.
Um, but there's a problem with that, I believe.
Mm.
Uh, this is kind of unfinished parent if you think about it, because this fold may fail, right? But we cannot commit on making it a parent of anybody yet.
No, 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 we're not going to make it a parent. We're going to set its parent to be the surrounding scope.
No, but it already has a parent, I believe. Well, not necessarily. Depends on which module you're compiling first. But assuming a file is a module, they already have a parent, no? In that case.
Plain signature. Oh, wait, this is for signatures.
Yeah, which is what we're doing.
Plain signature is a compiled signature. Step. Yeah, compile signature. Okay. Um, it's because, okay, we need to, yeah, this env here in the compiler is not actually, it can't be a signature, right?
The env is actually generic. It can be multiple things, actually. The env can be many things.
The env is a compiled module,
Which is 40, line 40.
which is line 40. Yeah, but this is, yeah, this can't be a signature is the problem.
It can, because a comp time can be a signature as line 41 says.
No, 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 no. This is a module T, Lemos.
What's the problem?
The problem is that the module T is this.
And what's the problem?
Mm, the problem is that the signature, the accumulator over there is this. Like, it's not the same type.
Yeah, but we can upgrade the compiled signature to be a full compiled module very easily.
We actually cannot because we would have to come up with multi-declaration for this thing, for the predicates. I guess we can just use empty bodies as a kind of a cheat.
Exactly. But I'm not understanding the why that's needed right now. Like, why is that a problem right now?
Because if we actually want to exploit the parent environment, right?
To the idea of not having to do like the nesting lookup thing.
Yeah, that means the signature that we're compiling will need to be the env of the compiler, but a compiled signature is not the same as a compiled module, you see?
Oh, but we can make a compiled signature a compiled module. We just need to wrap it on a signature tag, as line 41 says, and use that to create a compiled
No, no,
module.
no, no,
But
no,
then
no,
there is a
no.
problem of the multi-declaration.
Env is not a comp time, Lemos, is the problem.
Yeah, no, but yeah, I just said it. You make a comp time out of the signature using 41, and you can upgrade that to a 40 by doing the hack of the multi-declaration that you just said.
No, 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 no. Like this is not an upgrade of this. This is a component of this. See?
No, this is the other way around. Comp time is a component of compiled module.
No, they are mutually recursive. The point is we start with a compiled signature.
No,
And it's like, okay,
they are mutually recursive, but we're not using the other case of the module. We're only caring about the signature in this case. It's what you said, man. You said it yourself. You can make an empty body on the multi-declaration and you're done.
mm,
That's it. Like, I'm not saying it's a good solution, but that should work.
I guess.
Oh, but is that better or worse than the nested lookup? And if it's
Hmm.
worse, it's how much worse? Or how much better if it's better?
Hmm. It's a good question.
I think it's very... It feels very wrong to do the hack way. Particularly because um, you have to specify an empty body. Like, that sounds like a hack for sure.
Hmm.
We can also make compiled module a tagged union instead of being just module T.
That helps how exactly?
Because then we can make one case for the whatever module T is useful for, that the body is not, like the body being non-empty is the standard. And then we can make the other tag specifically to handle this case of the signature.
That already exists. It's called comp time.
Well, but that doesn't work for us because the env is not a comp time.
Well, it really shouldn't be a comp time.
Well, I agree, but that's a third solution. We make compiled module.
Your
Have
argument basically degenerates to, okay, let's change aim to be comp time.
No, that's not what I said. I said
But it degenerates to that because you're basically saying, okay, you see this distinction here? Let's undo it, basically.
also no. I'm not proposing that. What I am saying, however, is to allow comp time to be alone in one of the versions of compiled module. That's it. Because right now comp
But then,
time cannot be alone. It has to be related to something else. In this case, a multi-declaration. But in our case, it's useless that.
no, Lemos, what you're proposing is basically equivalent to this. And the reason for that is, okay, let's say that we do make this a tagged union, as you said, okay?
Mm-hmm.
If we do that, that means this will be like, I don't know, the current case can be module off, right?
Yeah.
And then the alternative would be, okay, we'd have to say handle a signature, right? Because the signature doesn't have a multi-declaration
Yeah,
here,
it would be
right?
essentially a copy of the second branch of the comp time.
You see the problem, Lemos? Those are equal now.
No, well, you are right because it's they are mutually recursive. In the case of the module, we are exploiting the recursion there. Yeah, I see the problem. Yeah, I see the problem now.
Yeah, let's undo all this. Hmm. Yeah, this is kind of tricky. Maybe we just accept the fact that we have to do the one level of the nesting ourselves for the signature case. Because like for the module case, it's easy. We can just inject this into, oh, we can extract it actually. Actually, we don't even need to extract it. We already have a compiled module in the module compilation case. We just have to build a compiler with it. That's easy. The signature case, yeah, I'm starting to think that maybe we just have to accept that it's not going to be as elegant as possible, because otherwise we're gonna have to spend a lot of time redesigning these types essentially.
I don't have a problem with designing the types. It's just because it's not the alternate. The allegedly alternative is not clear to me. Like as you said, to me the env makes sense to be a compiled module, but a compiled module is it has um, it sucks for some cases. So it kind of leads me to believe that it can be improved, but I don't see the improvement right away.
The point is that a signature doesn't have an implementation, right? There's no sense in talking of, well, we have something called compiled signature here, but that's kind of a misnomer. This is just a signature that has already been constructed, but it's just living there in the compiler environment somewhere, right?
Yeah, I don't think it's a misnomer. We compiled the signature. That's it.
Not really. We interpreted the signature. I guess you could call it a compilation because we're changing the.
Data structures.
Yeah, we're translating the source code of the signature into something that the compiler can actually use.
Yeah, that's what I
Um,
mean. I don't mean compiled in the sense of generating bean bytecode at all.
okay.
Okay, so it's also not clear to you what would be the improvement on the compiled module type to make this more elegant. So I think actually the elegant way is to just do the double lookup ourselves then.
Kind of sucks because we're kind of duplicating the lookup logic in that sense.
Well, it's not really a duplicate because you're checking given in like how should I say, in different environments. The one from the accumulator perspective and another one from the outer compiler perspective. So it's not the same lookup, it's just the same operation. My main worry is more if this is gonna how much boilerplate code this is gonna generate.
Well, I'm not sure if it will be much worse than this. Um, because we're kind of we're kind of already doing some of this, right? Because we have this lookup on the accumulator, and then if that fails, we do the lookup here. So we're kind of already doing it.
No, yeah, but I think we should not do like we should extract this pattern matching on set 378 and 383. We should extract that to a separate function because this is gonna be the same handling of the pattern match for both qualified and unqualified. Remember 375 means it's unqualified necessarily. We are creating a new branch of this pattern matching right now.
Actually, that does raise a question. Does it even make sense to talk about a qualified lookup in a signature?
Um,
Like, I mean, local lookup, right? Because this is doing the lookup in the accumulator specifically, which we know is a signature.
I guess it does because you can have like nested signatures before the current one, right? So you're implementing a module right now. But who said you cannot use the nested signature immediately above you? You see what I mean?
Right, if the signature has a module declared inside of it, like a module
We
declaration,
should put this on screen because I think we this is being recorded, so maybe we're like talking nonsense to people.
here. Okay, so the example you have in mind is something like signature, let's just call it nested for now. So the example you have in mind would be something like,
Another signature here, nested two, and then
nested 2.
inside that there is a nested three as well. And then on the same scope or level as
No, no,
nested
no, no.
two, you want to use nested three. That's what I mean.
The same scope. Okay, so nested 2 needs to have another signature.
Exactly.
Signature nested 3.
And then there is a module definition exactly there. And then the question is, can this guy use nested three? Anyhow, in any manner.
It should not be able to, actually.
Okay, so if that's the case, then qualified signatures for module definitions in
Uh,
already in signatures is no, as no-brainer then. It's a no-brainer.
what could be the case, arguably, would be if this was actually a module And then you say, okay, this is uses nested, and the signature is nested two, nested three, and this has no body.
Yeah, I see what you mean. It's because the signature is the conversation from the last time, right? Signature is a type, hence you cannot use it as a qualifier, but you can with modules because modules are containers. Then yeah, so the question is, should this work?
Mm, it should, but this is an abstract module, which means this is an abstract signature, which means, yeah, in terms of type checking, we would have to defer it to when this is actually instantiated, I guess. But in terms of should this work in the terms of just lookup, I think it should actually.
Okay, so we need to care about the qualifiers then on 375. We need to care.
We kinda do, yeah.
The question is, do we need to separate those cases, the qualified from the unqualified? Can we combine them in the same thing and just give it a name instead of an
Hmm.
empty list there?
We should be able to combine them, I think, because this is still just a local lookup, right? This nested two is defined in the same scope, right? Um, it's just not super clear what should be the semantics. Like, what should we actually put here?
What do you mean? Put where?
Because we have this ascribed signature to module, right? Actually, no, this is not it. This takes the compiled signature.
Yeah, this just upgrades something to a module T, essentially. A module T of some sort. In this case, signature unit. So can you go back?
Yeah, okay, here.
Okay, so continue. No, continue scrolling. We are compiling the compile signature. Yeah,
Oh
there you
yeah,
go.
no, it's here.
Yeah, but scroll up. Which pattern matching is this from?
It's
Continue
this
going.
one.
No, continue going up. Okay, so this is a module 2. Yeah, so this is the case of line 8. Cool. Um, understandable. Understandable. So the module signature that we are doing the lookup on 374 is actually the nested 2, nested 3. The first pattern match on 375 is if it's unqualified. The question is, can we make this the generic to any if it's qualified or not? And it should work regardless.
We should be able to, I think. Mm, let me think for a second. What happens if we try to refer to a local signature? Um, we do the lookup, right, of the.
Using the module signature name as the key, we grab the modules from the accumulator, and then we try to see if we found a plain signature, an abstract signature, a module signature, or none. If it's none, then we go one level above the accumulator on 397, and we actually look up on a broader scope, which is the env.modules instead of the acc.modules.
Right, so we actually have the base case, which is when we reach the last segment, but right now we don't handle any prefixes, essentially, right?
Yeah,
So, like, if we had a signature nested for, this should work, right?
nested for. Yes, this should work. But I think it was already working. Like maybe I'm crazy, but I think this would already work.
Hmm. Okay, so we need to do. Yeah, I think this works actually. We need to do. We need to do. Let me go back to the. Not
I
this
have
one.
a question though.
Yes.
Ah, okay, so it's a series of lookups, man. 374, no, 377 does the lookup locally, then 397 does the lookup on that module that we are currently compiling, and then
It
the
does inter.
parent
Yeah.
does the parent is even broader than that.
Yeah. No. This is when we start looking at the parents, right? Because the accumulator is a signature that we're currently compiling. Env.modules would be the module around the signature,
Which is the
basically.
one we are currently compiling.
Yeah.
Yeah. So and then the next level of lookup is grabbing the parent of that.
Yeah. This one we can totally do the. We can totally just use this. No problem.
Okay, I have a proposal.
Okay.
Let's grab 377 all the way to 395. Let's make that a function called local lookup. Then
Um.
we make 397 another function which is module lookup, and then we make the parent lookup. I think that's going to be more descriptive and less boilerplatey.
Why would we need a third one?
Because if this fails on none, we should not do what we're just failing. We should look on the parent.
This is already the parent of the signature.
No, but
And this is a module, which means we can just use the normal lookup that we already have.
but this is for the current module compilation. What if this current module compilation it has another module as its parent?
The lookup, we pass the entire env. Actually, we pass the entire compiler to the lookup, right?
Exactly. But the current env is for the current compiler. The current compiler may have a parent compiler, which is from the outside module, right?
Yeah, we would basically have to replace this find opt with the lookup dot signature.
Oh yeah, I'm stupid. We already implemented a replacement, which is that already does the okay, check myself and then check my father. Okay, perfect, perfect.
No, Luke.
Okay, anyway, so just replace the find opt with lookup dot signature, I believe.
Yeah, this would be okay. Module.signature is strip location, but that's actually fine, right? That's what we want. So, um, yeah, this would be lookup
Yeah, we didn't have to delete all of that, but okay.
dot signature
Okay, so now you need a
compiler.
compiler and you need a func label, which is a problem. So check line 374. What's the type of? No, that's just a string. What the type of that? Ah, fuck.
This is an
We need a
expression operand.
we need a lift function. We need something that lifts a string to a func label.
Well, a func label is a pair, right?
Yeah, that's a very easy lift to do. Very easy. But I think we should do it because I imagine we're gonna use this in more places. Like we have a more raw data type and we need to lift to func labels.
1 second. I'm trying to think. But I guess we kind of already have a func label. This would be like, I don't know, as
Signature
label.
label. Sure, that works. The pattern matching is probably fucked. Ah, I completely know why. The external nonsense. Okay, so 405, 406 can be removed. Nice.
405 and 406.
Yeah, this is not. Wait. Ooh, I forgot about that, man. There is a report module with signature function.
But we're already doing that inside of the signature here, no?
Yeah, but that means that maybe report module with signature can die. Well, it's being used in 396, so maybe cannot just. Well, just remove that. Yeah, that's fine.
We'll probably either remove it or incorporate it into the signature lookup. They are probably pretty similar already.
Okay, now you need to remove the signatures with capital S's on 400, 401, and 404. Because this is already being checked and unwrapped by the find, as you can see in 242.
And this has no location actually, so yeah, we can probably do this, right? I think.
That's a problem though,
Why?
because we are using the location to do something on the happy case or 402.
We're
So
using the location to do something on 402.
Uh, but, but, but the label has location, so you can use the location of the label, and fuck it.
We can use the location of the. Can we?
Yeah, you should.
Can we?
Yeah, this is required
After.
because the definition is being added to a map that has location in its type signature. Yeah, so we need a location. Let's just use the label one. That's fine.
This. Okay. Shouldn't this be the location of the definition though?
But, huh. Okay, you're kind of right actually. Okay, can we put the location back then in the value that we are receiving? Go to the
We
lookup module, specifically lookup signature.
we may
Are
be
we
able to.
stripping the location? Because I
I
remember
think
having
we
this
are. I
discussion.
think we are actually. Yeah, we are.
Yeah, so what we should do instead is to actually provide the locations embedded in the type. So just do an, no, you don't have to do that. Just do an S alias on 242.
On 242. That doesn't work because I want to unwrap this.
That's also fine. What are you talking? Just put the S
Oh
after the
yeah.
thing.
Oh
Yeah.
yeah, we have fmap now, don't we?
No, but we don't need it. Just do an S here. It's fine.
That doesn't work. I want to unwrap this, Lemos. Is the problem.
Ah, okay, I'm stupid. Well, you can either use fmap or you can construct it yourself with the add lock.
Mm.
Add lock seems prettier, in my opinion. Because the fmap is going to have to do pattern matching, which is kind of nasty in a lambda.
It would also need to actually like have an unreachable because, well, we know this is the case, but the type signature doesn't know, right?
What do you mean?
Because we're gonna pass this whole thing. We know it's the
No, we
tag is
won't. No, no,
signature,
no, no, no. We
right?
won't. Signature is being extracted on purpose, and that's why we're
No,
going to
no, no, no.
remove from the buffer on the left.
No, I mean, if we do the fmap approach, right, we would have to do the fail with because we know this is the tag
Ah,
because of
yeah,
the
no, you're
pattern
right.
match.
You're right. You're right. You're right. It's going to become even nastier.
Location, not with location, right? Oops.
Yeah, and then you just do sum at. This is not a function because
Yeah, this is
man,
not a function,
man,
Lemos. Welcome to
man.
OCaml.
Ah.
Welcome to OCaml. Uh,
Ah.
which makes me think maybe we should add the location in the other lookups as well.
No, we will. We will. We are just doing signature for now because that's what we currently need.
Oops. Location, add lock.
This should just be add. Like, man, my names. But sure. Perfect. So now that means that yeah,
We
the
can get rid of
strip
this
yeah
and
strip that.
this.
The parentheses can also go away probably.
Yeah, this just
Uh,
works, actually.
404 is kind of weird.
404.
This is very weird. 404. Ah,
Hey,
this
what's
is
the
an OR
problem?
pattern. This is an OR pattern, my man. Sure. So just do the following. Remove the... What's wrong? You remove
We're
the
not using
signature.
alter, actually, so this can be
Yeah, sure. That's fine. That's actually...
this.
Yeah, no, that works. Yeah, that works. Okay, so that's good. We replaced the inner lookup with the double lookup via the parent thing. But I still have the problem on 377, right? So 377 is still pattern matching on unqualified shit, and that should not be the case anymore.
Yeah.
So what can we do about it? Do we need to do another branch, or can just use a binding on 377 and use the name for something?
Mm, well, we have the label, and the label is what we actually need for the actual lookup in general, right?
Yeah,
So this can probably be this,
that's
but
bold, very bold.
I mean, we're not really losing it because we're using it
I
here, right?
understand that.
And
No, I understand. I understand. Um, okay, so let's see if this compiles and run an example, because apparently this already is doing signature with qualified names.
we're not handling it properly though because we're still using the find opt here, right?
Yeah, you're right. Yeah, I have to change that. So it's a lookup.signature, but we have to update the compiler to use our new environment. That should be easy.
Mm, actually, there's a slight problem. This doesn't work for our case
What do you mean?
because like this returns a compiled module, right?
I don't understand. Why are we gonna use the module one in here?
Well, actually, we're gonna use the signature one, but the point is the lookup nesting expects that we're going to do um, not here. Yeah, it expects a module, right?
Uh, ah, it's
But we
because
don't
when
have a module. We have a module signature actually, which is in the signature case of the
yeah,
comp time.
but if we find a signature, the lookup mod sig is failing because of the whole type discussion from last time. Okay, so we
Yeah,
either can make another function that deals with this case specifically, or we can undo the error case on the signature and just
the
let it
error
fly.
case.
Yeah, because right now, if in the nesting we find a signature, we just blow up. We can undo that behavior. And we are blowing up because of the whole thing that you cannot inspect types.
Mm,
Actually,
yeah,
okay,
that's kind.
that was part of my confusion then. That was why it took me so long to understand what you were saying, because to me, I already had the intuition that we are treating signatures not from the programmer's perspective, but from an implementation of the compiler's perspective as a bucket. And that's why I was
Um,
confused.
well, the compiler needs to look at it as a bucket, but logically it is a type. The thing is, when you're inside of a type, you're already analyzing types by definition, right?
Sure.
So in this case, we need to be able to look up like the if a signature has a nested module which is translucent and has another signature inside of it, you should be able to reach that nested signature, but we can't at the moment because of this distinction, right? Because this is this case, which is an error.
No, but that's what I'm
What
saying.
we
No, it's not because of that. It's because of how we are treating the pattern matching on signatures and the lookup mod sig. That's why.
yeah, what we can do is like we already fixed this partially because if we have a qualified name, right? This is not going to match because we're ignoring the qualifiers.
Yeah.
This is not correct, actually. We need to.
Yeah, we need to use lookup signature here. But here's the thing, man. What's the problem of undoing the error case on the lookup mod sig?
Undoing the error case in the lookup mod sig.
Like, I understand where you're coming from about like you should not be able to inspect a type, but from the implementer's perspective, we now need it. So what about
The,
just allowing that to happen?
the problem is that this lookup is used for both modules and signatures, right?
Yeah, but the responsibility of treating the outcome, aside from being a complete error, such as line 205, should be the responsibility of the caller of this, not from the responsibility of this guy. So for example, if you are treating signatures as a type, you need to handle that yourself, not look up mod sig.
That's fair.
So that's
That means
man.
this needs
Okay,
to
so
look up
this is
an option
okay. So
now.
I
Yeah.
was tired, but I was also not completely insane. I was so confused by this at the time, and it was now I understand. Now that I have more context, it's because my mind already sets everything is a bucket, everything. But to me, I am the implementer of this thing. From the usability perspective, they are just types. You cannot do that. Yeah, no, it makes complete sense. Complete sense.
Yeah. Part of the difficulty in implementing a language is that you have to keep both perspectives in mind at the same time.
Yeah, but I think that we got to the solution, right? So choose 207 should not error and exit. It should completely just fall through, and then whoever is calling lookup mod sig, which is going to be many people, at least two people, we have to go in which one of those people and change it accordingly.
Right. Um, well, that means this actually can't just fail. It needs to actually return an option now, right? We need to change the signature. Um,
It needs to return an optional.
yeah, because if we want to make the caller handle this, right? Right now it's just blowing up. It's calling exit 1 directly.
No, 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 no. But 205 should blow up. That's true. I'm talking about 207.
207. Yeah, but
Yeah.
to make this work, this needs to return none, right?
Well, but we can also exploit. What is the type return of this guy? By the way.
This doesn't have an explicit signature, but it's in fact a
Oh, it's
comp
a
time with
comp time
location.
location with location. Comp time with location. Can't we just always return that in the case of signature? Like again,
Mm,
whoever is calling lookup mod sig needs to do its duty. So if you are compiling a module and you're receiving a signature, you need to do something about it, not us.
right. In that case, let me think for a second. We're doing this, and oh, I know why actually. It's because this is not the case where we reach the end of the qualified name, right? This is the case where, okay, we're in a segment which is not the last one, but we hit a signature. Which is different from the case of, okay, we reached the last segment and now we can return whatever, for sure. Like, the lookup is not complete at this point yet.
I understand what you're saying. I understand what you're saying. That's tough because from from the point of view of the buffer on the left, we need to go deeper. But from the point of view of the guy on the right, going deeper is a mistake. That's a good question. How do you solve that?
Mm,
Are we gonna have to copy paste lookup mod sig and do it specifically for this?
actually, I just thought of something. If we go back to here, the question is, module whatever, and then we say, okay, there is a signature which is inside of whatever, so let's just call it inner. But this signature declares it declares another signature inside of it, double inner, which is abstract, right? There's
Uh-huh.
nothing really. But then inside of here, we say module um, whatever the second. And we have to say that this must satisfy, but this is abstract, which means
Yeah,
that
you
doesn't make
cannot do
sense.
it. Yeah, you cannot do inner double inner. It's the exact same situation as the nested and nested shoe above. You have to have a module in line 14. You cannot have a signature.
Ah, I know where this is gonna give us problems in the future, Lemos.
Tell me.
What if this was a functor?
Man, but we are not implementing that. I understand. Okay, here's the kicker. If what you're saying is going to completely make the implementation of functors miserable, then we should care right now. If it's just going to be hard but not miserable, then I don't think it's debatable.
Because here's the thing: if you have a functor and you say that whatever needs to be of this inner signature, let's assume this is defined somewhere else, right?
Sure.
Let's say that whatever has to be inner, which we know there's a double inner defined inside of it.
Yeah.
At the point that we call the functor, that will not be an actual signature but a module.
Yes.
Ah, which means actually we don't hit this case because we're at that point we're looking at a module. Okay.
Yeah. I guess I followed. Yeah.
Never mind then. Functors are not particularly more difficult in this scenario.
Okay. Anyway, so here's the situation. Going back to the original situation. The lookup mod sig is doing the qualifier is like walking through the qualifiers, and at the moment that you hit something in the middle that is a signature and it's not the last one, that's an error because you should not be able to do that with a type. However,
Yeah.
the guy on the left on the batmap string thing, that should be doing a nested lookup, right?
Yes, and in particular, we need to be able to continue from where this stopped.
Yeah, that's very fucked up, man.
Hello, and where are my modules, Linus?
We're working
Well,
on it.
yeah, we're working on it. Fucking lexical scoping, man.
Oh, so you guys are dealing with scoping now.
Yeah. Uh, okay, I have a proposal, Marin.
Okay.
I don't know if I like it, but it's at least an idea. Here's the thing. We should we can upgrade the type of lookup mod sig to return a result type. And if you encounter a signature, instead of just dropping it, we return an error tag with that point of error. Like in 207 there is an underscore there. We can pick that value and pass it to the error tag. And then the lookup mod sig never explodes, aside from 205 again. And then we can return this signature for you to continue going on the left case.
Hmm.
You see what I'm saying?
We, yeah, we can do that, I think.
Yeah, I think that's gonna be the most like not copy pasting shit option.
Okay, that means we're gonna have to change a bunch of places, but that's fine. Let's do it.
Yeah, so the first thing is that the return of lookup mod sig qualified needs to be a result. And the funny thing
Um,
about results is that I don't remember. I think it's the no, that's not how that works. It's not Haskell. It's the guy on the error first, then, ah man, can you show me the
Okay.
files that we have inside lib?
1 second. Is
For
the
this,
error
it is
case
for the result it is okay and then error as a tuple.
Yeah,
okay?
but that,
So
yeah, but
that
that's not.
means
I don't think that's how you do it. I did this before in this project. So just open the.
It's comma,
Yeah,
Marinho.
it's comma.
and then the other case would have to
Comp
be
time. Comp time. No. Signature, right? Just signature.
it needs to be a signature. Do we want
Well,
to include the location?
ex well, not only that. The question is more like, are we gonna have other error cases that we can exploit this mechanism? So we should upgrade it to comp time instead of being dedicated to signatures. Are we gonna suffer from a similar
Mm,
problem with modules? That's the question.
we already handled nested lookups of modules.
Yeah, but what
Yeah.
about future functors again? Can you foresee the
Mm,
future sufficiently good enough to say that
yeah, I
when
don't think handling. I don't think modules will be a problem in this case
yeah, so just
because
do signature with yeah, just do signature with location there then.
that can't be the case because we actually also need to return the remaining qualifiers that we haven't stepped through yet.
Uh, that's so annoying.
So yeah, this actually needs to be this actually needs to be
That's so annoying. Ah, that's so annoying, man. Um,
yeah, there needs to be a list of this needs to be this plus a signature basically.
and location on both, right?
And we need the well, we don't need the location on the list, but we do need the location on the signature, yeah.
Yeah. Wait, we need a location on the list, man. Because if we're gonna
We
continue stepping through the
don't
qualifiers, we may have a problem in the middle.
we don't because the items of the list already have locations.
Ah, no. I didn't mean location of the entire list, man. Of course. I meant the items.
Uh, okay, let's make yeah,
Error
let's just make
signature.
another
Error
file.
signature. Error signature. Lookup
Let's
error.
call it remaining um, lookup, I guess, equals. There's going to be a record, and there's no semicolon.
Okay, let's actually explain to Mageta what the. Oh, okay, he just
He
dropped.
dropped.
Okay, but there is an man. Can you open the file explorer on the left? Because I think there is a thing you can do to make
The
this.
file explorer.
Yeah, just look at the files on the lib folder. That's fine. Open error. Yeah, that line 16. Yeah, so I think we should make an alias for the result as well because that's gonna be really bad to keep pasting results around. So I did this for the executor to save my time.
Okay. Well, I guess this can just be result, not result.t.
No, but you're gonna make an alias for that. That's kind of what
No,
I'm
I
saying.
am. I just need to do this first.
Yeah,
Okay, so
this
the
is gonna
signature.
be a column signature with location. But now I hope OCaml is gonna know what to do with this. And then there will be another thing called remaining
Remaining
qualifiers.
segments. Could be qualifiers, yeah. Actually, technically, the last one is not really a qualifier, it's the actual name.
Yeah,
So.
you can call it names or segments, it's fine. But segments reminds me of Warm in the Brain though.
Oh, well, those are the segments of a name, which is qualified. The last
Uh,
segment is the leaf, which is not a qualifier, it's the actual name of the thing in the given context. And
Yeah,
the segments before that are the actual qualifiers that delimit the
yeah,
context in which.
yeah. But
Yeah.
I think Mitchell would not like segments anyway there. But anyway, let's just go. So this is a string with location list, right?
Yeah.
Speaking of Mitchell, I bought his last and fourth book available. It was the last one.
That's very nice. Uh, do we want this to be parameterized?
No.
Okay. Hmm.
Awesome. Awesome, awesome, awesome. Okay, so 205, and that's not how
Actually,
it
this is
works.
okay.
Okay, yeah.
Let me fix the type errors first, actually, because that's gonna bother me. Okay, so signature, this is doing this. So those two cases are actually okay and okay.
Yeah, but now we have a fourth case, which is error. And the error will have the stuff. The question
Mm,
actually is, what should we do? Should we try to do some default behavior? Or should we
yeah,
let the caller
actually,
handle the caller handle
actually,
it?
yeah, actually, this should be parameterized, in fact,
Why?
because this needs to be okay. Because this is a comp time,
Ah, I see. It's
but
because
the
we're not you were unwrapping the comp time. Makes sense.
yeah, but the one down here is a signature, right?
Yeah, no, that makes
So
sense. That makes sense.
yeah, so huh?
What's the problem?
What should we do here, actually?
You encountered a module successfully,
But this
and
is supposed to be a signature, yeah.
we should. Wow, wait, that's kind of confusing. So we are looking for a signature. We found a module. What should we do with that information?
Yeah, before, when this was an option, we were just returning none. The problem is, what do we replace the none with? Because like we don't have a signature to put there,
No, 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 yeah,
actually,
no, yeah.
in the remaining
I
lookup.
see. Okay, the first solution is to make lookup result be even more parameterized, right? But that would be unit
Yeah.
anyway, which is terrible. This is tough. This is actually pretty tough. Not gonna lie.
Well, it doesn't have to be units.
Yeah, but you're gonna do nothing with the information essentially. It's a none, but you're not able to express a none anymore because the type needs to be a result.
I mean, we could return the module in that case.
Yeah, but that means that the burden of dealing with that is gonna be on the caller.
I mean, the caller can just choose to ignore it in the error case.
I guess that's an option. I guess. But then it defeats the whole purpose of having signature and module as separate functions. Aside from the error messages, I guess, the error reporting, that we haven't implemented to be conditional on the dynamic scoping thing. Man, that's tough. Man,
Mm,
can you explain to me polymorphic variants? Is this a use case for that and I just don't know because a skill issue?
polymorphic variants. Not really, because we don't need a set of alternatives in the error case to be open. They're just different in these cases.
Oh, but isn't different a use case of open? Again, I don't know what I'm saying, so maybe I'm saying bullshit.
Mm, hmm. Would it be helpful here? Well, one way to think about it is polymorphic variants are basically like tagged unions, but they are structurally typed, which means that the identity of the type is not based on the definition site, it's actually just based on the structure of the type. So as long as they are compatible.
Yeah, I was kind of thinking of using dash to return option instead of a lookup result. And then the content of the option can change or something like that. Like the type of the content can change. Because sometimes I want to use none and sometimes I want to use some, but the none of this and the some they have different types. Like I don't know if I'm saying nonsense, but that's what I thought. Maybe I am saying nonsense. It's hard to say. Because here's the thing. Here's the thing. If you are in a signature, what are the cases that you care? If you encounter a module, we should ignore it. And if you encounter an error, no, an OK with a signature, we should return that. But if you encounter an error, you also need to return that. Agree?
Mm, if we encounter an error, we also want to return that,
Yeah,
right?
it's
Because
three states. We have OK, successful, but we don't care. We have OK and we care, and we have an error. The problem is that to do the don't care with the result, you need to use probably some nonsense, or you put the burden on the caller. That's why I'm trying to see if there's another way to do this. And again, I don't know polymorphic variants, and I really want
um,
to know how to do that.
yeah, they probably would help actually. They probably would help. They just have funny syntax, and I can never remember what it is.
It's backtick.
Hmm. Mm, okay, let's say. First of all, let's get rid of this for a moment. And let's say that was the OK as signature. And this is not a keyword. Okay. So instead of exiting, this needs to return, I don't know, found signature.
Hello,
Um,
hello again, Magita.
Hello. Patch restart.
Okay, let's actually
how do
ask.
we
Okay, go on, Tell me.
how do we express this? Like we found a signature. It's not a leaf, which means we need to continue the lookup, but we can't because it's a signature. How would you describe that, like in English?
Uh, Wait, repeat again.
Like
You found a
we're doing a
signature?
nested loop. We found a signature,
Yeah.
but we haven't finished the lookup. This is not the leaf, which means this should be a module, but it isn't. Like, how would you describe that?
found unexpected signature or something like that. That's
That
the
works.
that's the part that I will
Unexpected
go. Let's
signature.
ask Mageta's opinion. Mageta.
From what I understood, you found something that should be a signature.
No. I want that's not what I want
Or-
to ask you.
Okay.
What I want to ask you is the following. We have like we are implementing scoping, which means that we implemented lookups. Right now we are capable of doing lookups with qualifiers involved in the equation. So you can do like module, column, module, and then your thing.
Okay.
We have a situation that if let's suppose that you're looking for a signature. There are three cases that we care. So first, you found a module with that signature name, and you don't care about it. You're not gonna do an error. You just don't care. You just let it like proceed. Do nothing about it. You are the lookup function. You're gonna return like none in an option. That's the first case.
Okay.
The second case is that you found the signature you're looking for. So you grab that, you put in a sum, and that's it.
Yeah.
And now the case that we're introducing today, which is you found something that you were not supposed to be there, but we need the what you found already to be returned as well.
Uh, wait.
Yeah. Okay, let me repeat.
That's
So,
confusing. Give me concrete scenarios of how that could happen,
fuck
because
me.
I couldn't
Okay.
figure it out.
Okay, so the scenario is the following. I'm not gonna bother Marinho because he's writing an attempt of a solution. So I'm gonna explain in
Sim,
abstract
Marinho,
terms.
sim.
And here's the situation.
Okay.
You cannot use a signature as a well, like imagine that you're implementing, I don't know, you're programming in SML and you have a
Okay.
signature and there is a signature nested inside that signature, that first one. When describing a module, and you cannot do like signature one dot signature two because the signatures are types, which means that they are not buckets to be explorable. They are not explorable in that sense. Do you understand what I'm saying?
Yeah.
Yeah. So that's the situation that we are because we are in one part of the compiler. We need to interpret signatures as buckets because we need to keep because of the lexical scoping. We need to go further. But our lookup functions, because types are opaque, if we encounter a signature, we blow up. But now we want the outcome before blowing up. So imagine you are doing a bunch of qualified nesting lookups. So like, oh, there is this module name, look for that. Then there's another name, look for that. And you keep going. Right now, if at the moment in the middle of the columns that you found a signature name, you're fucked. And we just say types are opaque, you should not do that. But now we are in a situation that we need to know, we need to grab that point that you blew up, and we need to return that. I'm not going to explain why. Just believe me, we need to know where you stopped in the
Okay.
lookup process.
I am believing. I am believing in you.
So
Okay.
the situation, okay, so this created a three-state situation that now you are looking up for a signature, you found one, and then we return a
Mhm.
sum. You found a module, then you do an error and return a none. But now there's a third case where you were looking for something, and in the middle you blew up, but now we need to know where in the middle of the lookup process you blew up, and we need to return that as well. So there are three
Okay.
possible outcomes
So,
of this function.
and what do you want to ask me?
Which type would you use for the return type of that?
That's a good question. Um,
Man, I can't believe I was able to explain that shit.
so it's not just a matter of error, right?
Yeah,
Although you're
it's not.
probably treating an error, but it is a. I would
It
probably
is
make.
essentially a three. Uh,
Yeah, I think the only solution is actually
a,
a
like the
union type.
Yeah, exactly. But the first approach that I had in mind was we use a result that is parametric on both sides.
like an either.
Yeah. But then,
I think check if OCaml has choice. Maybe it does. Let me see.
okay, that's actually a good idea. Choice type. And then I
That's
ask
an F sharp.
Marinho, man, is this a good use case for polymorphic variants? That's what I asked him. He said he was not sure. And now he's typing a bunch of backticks.
He's typing a bunch of backticks and something will work.
Yeah,
Out
because
of that.
backticks is how you do polymorphic variants. I don't know what they are. I'm still waiting for Marinho to like give
Oh,
me
you mean on
the
on
sensei
the
thinking.
unions,
It's
right?
it's basically just structural typing for tagged unions.
Yeah, that's the same thing on SML as well.
Okay, so it means that it's a type that is only identifiable by its structure.
Man, you know what would be more elegant than this, maybe?
What?
Active patterns. But I don't know how to do that in OCaml.
I wait. Is active patterns?
Functions, what's the name of the functions that you put on pattern matchings in
Oh, that
Haskell?
okay. View
Forget it.
patterns in Haskell.
View
And
patterns, yes.
active patterns in F sharp. I see.
I don't know what they are, if they even exist in OCaml. Let me see.
I don't think they do. But I don't know. I don't know. Look at okay. Marinho finished, right? Marinho, this compiles this signature function.
It does.
Okay. So here's the situation, Mageta. Look. Okay. So you see line 244,
Submission the
240.
tag, that's right.
Okay. Why do we have two cases on 249?
Because those are the default cases that are error cases from the underlying lookup mod sig.
But I thought there would only be one. Why we have two?
Because I added this. This was
Ah.
another exit one.
Okay. So now the log mod sig doesn't blow up anymore at all. No, it does, but only on
Okay.
211. Okay.
Uh,
Okay. Go, scroll down a little bit,
Um,
Marinho.
so what Marinho did apparently is just to do the so when
yeah,
you
this
do
would
a
be
union, they all belong to the same type, right? In that
Yeah,
case, they're just they're on their own. So that's the only
exactly,
difference.
exactly. So the way that this
Um,
works now is the following. So see line 244, 248, and 249. Okay, so 238 says we are looking for a signature. This is a lookup module. 238 says we are looking for a signature. Cool. 244 means you gave us a name that is actually corresponding to a module and not a signature. So what do? We log some stuff saying that you made a mistake, and now we are returning what we're gonna be potentially gonna be ignored by the caller of this function called unexpected module on 247. 248 is when you found what you were looking for. Then it does this thing, which is okay, and then you just add the location, blah blah blah, doesn't matter. And then 249 does the what I was explaining to you, which is new for today, that we need to know where we stopped. And then apparently Marinho introduced two cases for that, and that's what we're going to return on 249.
yeah, this case is okay. We found a signature, which is not a module. It's just signature. It's a type.
Yeah, which is
But this
opaque.
is not the yeah, but this is not the leaf. This is not the last segment of the name, which
Yeah,
means we need to continue, but we can't.
yeah,
So here you go.
but it's not the responsibility to continue this function. That's the purpose of this return. We need to return this because the lookup function doesn't care about the remainings of a failed lookup. Doesn't matter. It just trashes the search. It's done. But today we discovered that we need to know where we stopped. And that's why we're returning this thing. So my first idea was to make a result type that is parameterized. You brought up a good idea, which is to use choice instead.
maybe it's not. I mean,
Isn't choice just basically the same thing as result?
No, because it has three
no.
cases
It's
instead of two.
not only three. You can have like any, like 5, 10, 11.
There
Doesn't
is a
matter.
library.
No. Forget about it. No.
Okay, Marin, what's your opinion? You just implemented it. Do you look at it and are you satisfied?
Uh, I'm okay with it, but then I like structural typing, so I'm kind of suspicious to ask
And
this about.
I think this like I think this implementation is good. I just think it would be much better if we had like view patterns,
Can
but
you
we don't.
explain to me
I just
why?
so basically there are two in F sharp. Haskell probably has two. So uh,
No, I know what
active
it is.
parent,
No, I know what it
yes.
is.
Does Marinho know?
Uh,
He probably does, but
okay, let me
Well,
remind him. I told him already what this does. Okay, so Marinho, view patterns is the ability to pass a function, apply a function to a value, and then do the pattern matching on the result of its application instead
so
of.
instead of
Go on,
yeah,
go on.
instead of match then compute, you compute then match. I
Exactly.
think that's the
That's exactly right.
so there are two ways to do that in F sharp, and I think Haskell there might be as well. So you can be exhaustive and limit and describe all of the cases and basically define functions that will categorize the things for you. And there's the other, which I think would fit here, which is you just make a function with a partial active pattern, and that will basically be if this looks like this, like if the computation follows to be the case, then pattern match with this guy, which is exactly what you did, but it would be just separate functions for each
Yeah,
one of them,
open the
and then
link that
just
I sent in
compose
the
all of them.
chat, Marinho, because maybe that's just too abstract because well, there's no visual reference for you to look at while Mageta was explaining.
Here, the the Microsoft Docs, pretty good actually. And like I am like it's obscene that this doesn't exist in OCaml.
Well, let me actually check that out though. View patterns, because I think it doesn't, but maybe it does.
Maybe there's a PPX for
Okay,
that.
AI said OCaml's powerful pattern matching does not natively support view patterns.
Oh yeah, of
Uh,
course,
oh, there is
PPX
a
view
PPX.
pattern
There
language.
is a
Yeah,
PPX, yeah. Oh, it looks terrible. Damn.
like usual,
The
I would say.
syntax is horrendous.
Let me see. Example Haskell. What the heck? Join list ML. Oh, this looks absolutely disgusting. You basically do like the syntax for the show rights to deriving. Oh man.
It's terrible. It has only 12 stars. Really? So sad.
view patterns.
Yeah, look
View
look at
patterns.
that. Okay, open the
Let me
link.
see the Haskell
Open
one.
yeah, open the link there. Okay, so here's how this works. You have this type called type view there. You can ignore the test. Just listen to me and look at the examples. You have this type, which is an NDT. Cool. You have a function called view that receives something else, which is opaque, and returns a type view. Okay?
Okay.
And now skip the next example and look at the next one. Imagine you have a function called size. No. You scroll down too much. Yeah. You have a function called size. That function will receive. Scroll up a little bit just for us to have the types on the screen. Yeah. That size function, as you can see in the type annotation, no, the type signature up there, it's going to receive the opaque one. Okay?
Okay.
So, if you have a function, view, that accepts that and converts to the other one, which is the one that the actual ADT that is not opaque, instead of having to do that in a two separate steps to make it happen, of like grabbing the value of the size, then you do a match, applying the view to the argument, and then pattern matching on unit and arrow, you can do it in a single shot like this. So the argument of size first goes to view function, and the outcome of that is being pattern matched after the arrow. Do you understand?
Yeah.
So
To
this
make it
gives
more
you go
palpable,
go on, Mageta.
to make it more palpable in the OCaml, how that would look like. Check the link I sent. That's an example of how it could look like, but it doesn't.
how it could look like, but it does.
Depressing.
It looks so terrible. Oh, it's the F sharp one. Actually, I don't remember the syntax, so let me see.
Can you pull that up, Marinho?
Yeah, there is a
Uh,
link in the chat.
So there are two types. There is this, which is basically yeah, that one, the even odd. That's a good one. So that is the complete one. So you basically just describe all the categories, and then you make a single function that categorizes the value, right? So whatever you feed to that input will already be matchable with that rule. You see, so like it has to be the module of two has to be zero, the remainder, right? So you're basically doing the input there on the match. So match input with, and then you can already match even odd there. So you can
mhm,
hide the computation, you see?
I see.
And then you
It's
describe
essentially
the
a
rule.
very convenient syntax sugar, man.
Now, but check the other one, and that's what I wanted to show. So what I think is more powerful is this one, which is the partial application of them. Actually, go down. I don't like this example. Yeah,
Partial
you see
application.
this integer float. So this is there's a single input that is shared between all these functions, which is a string, and they all produce the same. Well, they all compute in different ways. In this case, you're trying to parse which kind of thing it is, right? And then
Right.
you just define then in separate functions, and then you just compose all of them together. So I think this would be very elegant, but well,
Yeah, and
say la vie.
how can we do this in the OCaml program? In your case, you are essentially like pattern matching before and converting that to the other type, right? We can do that with a simple function if we had view patterns in a nicer way. That's what Magetta is saying.
I see.
Yeah, I used like loads, like tons of view patterns when I can in Haskell
And
because
they clean up the code in like I was using this for validation. Like when I was doing event sourcing, I had like
it is being
cryptic
recorded, by the
rules
way.
to validate. Yeah, that's fine.
Yeah.
But when I had like cryptic rules to validate, so you just make a pattern like that, and then you just hide the implementation, and then it looks like just business rules. You see, looks very readable. But anyway,
Yeah. Yeah, but it's very different how F sharp does it. It's very different than the Haskell one.
Comp time. This is not comp time. This is a signature. Ah, this is returning an actual comp time. We shouldn't, in fact. This is an error.
Wait, what is this case? Ah, okay, that's a bug. Aren't you
And
missing
this
parentheses? You
can,
definitely are missing parentheses, man.
this can go
218.
away.
218, it's missing parentheses.
218 here.
Yeah, you close another parenthesis. No, 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 you're right.
I'm
No,
pretty sure
no,
this is here.
no, no, no. I'm actually maybe no. I was mistaken. No, it was right. It was right before.
I
Just
mean
the
here.
control.
fact that there's a PPX for these is just sad.
Yeah. No, no, no. It was right, Marinho. I said bullshit. I think.
Oh yeah, this is a match. So this closes
Exactly.
here.
Exactly.
Yeah,
No,
this
yeah, it
closes
was right.
here, and
Yeah, it
now
was
we
right.
have an extra.
Okay, so let's see how this looks like now. So we are using the polymorphic variants, which, as far as Marinho explained to me, it's essentially structural typing.
Uh, yeah.
What's the return type of module now? Can you show it to me? And then we're gonna have to pattern match those
Yeah.
in the. Uh huh. Uh huh.
And now for predicate, and this is returning an option of multi-declaration, right?
Yeah. Wait a moment though. If this is a structural typing solely, what's the benefit of using that in general?
What's the benefit of doing duck typing in a dynamic language?
What's the benefit of doing duck typing in a dynamic language? Isn't it the whole extensibility thing?
Yeah, structural typing is basically duck typing, but with static types.
Yeah, but we are not really in a situation of the extensibility being that useful, right? Because we could just make the type ourselves. Well, doesn't
Uh,
matter.
we could, but we can let the compiler do it for us.
No, yeah, I see what you're saying. I see what you're saying. But I'm a little bit skeptical that no, it doesn't really matter because this is just going to be used for lookup, so it's fine. Anyway, so yeah, Mageta, that's essentially it. And okay, and then the question: why do we need to know where we stopped? That's a good question. We need to know that because we're gonna use it. We're gonna essentially continue the lookup even after it failed, because in the context that we are implementing right now, we should go further. The lookup doesn't go further because you cannot, like a type is opaque. You should not be able to do lookups on a signature.
Mm-hmm.
But on the context of the compiler implementation, we need to, because the signature is also a bucket for us. So we are kind of like, we either duplicate the functionality to make a lookup for the users and a lookup for us, or we hack the one we made for users to allow us to also continue the search if we need to.
Mm,
You're seeing.
It's hard to explain. I was talking to a colleague at work this week on Tuesday, and I was like,
Mhm.
man, doing extra scoping, like I'm not saying the Python people are justified. Like whatever they are doing with the industry, they are getting billions of dollars. Yeah, so they're not justifying for fucking up the scoping, but it's not as trivial. I was assuming to just say, oh, they're just lazy.
Well,
They are
if you
lazy,
have,
but not to the level
you
that I
can
thought.
argue, you can argue that if you have infinite manpower and you don't do it, I would say
It
you're
is
still
lazy.
lazy.
Yeah, no, they
Yes.
are lazy regardless of the infinite manpower argument. It is just that I have like 0.0000001 more sympathy.
there we go.
Okay, so this means that our lookup functions are now capable of dealing with all the scenarios, including returning from the state that we error out, right?
Yes. Just one thing. Can I get away with just saying other here? I can't.
No, yeah, you can't.
Okay.
That would be very surprising. Um,
Uh,
okay, so
Can I get
now,
away with doing this though?
wait, what?
Like,
Oh,
does this work?
that would be awesome, but I don't know if it does. It does. Damn.
Okay, this is better actually.
I feel like it's both for the same expression, right?
Well, I guess
So
it also has the same ergonomics of normal pattern matching because this
what
is
was the
very
code
doable.
before?
Sorry.
What was the code before?
The code before was returning options, just like
It
plain
was
old
returning
options.
options and it was calling exit one in a lot of cases as well.
Oh, I see.
Yeah, so now we are
That
not
that is
handling
indeed
failure at
cursed.
all.
That is
We're
indeed
s-
cursed.
we're still logging though. We may want to move these at some
No,
point,
no,
but
no.
for now it.
No, I don't think we should. I think we should do the dynamic scoping thing that we talked last time. Okay, let's also explain that to Mageta. So Mageta, the situation was the following: we had we implemented the lookups, and then we were like, okay, if in these scenarios we're going to do an error and exit, but at some point we discover that we cannot exit because some situations having a fail on the lookup may not necessarily just stop the compilation process. This can mean something else in the compiler. But then we were in
Mhm.
debating of, okay, we either remove the logs and keep pasting them everywhere that it actually fails, or we keep them and we use the level mechanism to suppress them if we are in an exception case. We went with that option.
I have a quick question. I know we have polymorphic variants. Do we have polymorphic records as well, like row polymorphism?
Let me see.
Wait,
Row.
if we have what? Row level polymorphism?
Row polymorphism on records.
In
You know
OCaml you
camel.
do. Yes, you do, I
Wait,
think. F
you
The
sharp
do?
you don't.
AI is saying the objects do.
Ah, the objects, but not the
Yeah,
records,
I'm not
right?
sure. I know OCaml does, but where, I have no idea.
Yeah, but let me check. Let me check more stuff.
Yeah. Because that would be nice. That would give us full-on structural typing, but I don't want to use
Ino
objects because they are
I know, so
mutable
we
Inocaml.
by
can make
default.
objective camel.
Yeah, Inocaml. The AI is saying Inocaml standard records are not row polymorphic. Instead, OCaml uses row polymorphism to type its objects and polymorphic variants.
Oh, that is so cursed.
Ah,
We can
and
convert the
objects
code to be object oriented.
and objects are all the fields are mutable by default, right?
Let's see. Objects fields are mutable by
They're mutable
default.
by default, yeah.
Ah, so Marinho is not taking it.
Yeah, no. I want row polymorphism, but I don't want to give up immutability. That's silly.
Well, anyway, so if we have these functions, now we can use them, right? So the code should have broken already. Like line 400 should be broken, like completely fucked.
Oh yeah,
Yeah, this is
it
the only
is
place that we are
actually.
using it. So let's change it. So this is OKs. Both of them are OKs, right?
They are all
Uh,
cases actually.
okay, we don't care about the other two in this case. That's what you're saying.
Oh yeah, and this is not none.
Everything
This
else.
would be the everything else. Yeah.
Ooh.
Let's actually spell those out.
Yeah, so
Um,
that's a good. I have a question. When you're using structural typing, you have to be like catch-alls are even more evil.
they are, yeah.
Okay, they get worse.
Mm,
I see.
unexpected module can also happen here. Okay.
Wait, unexpected module. Uh, but it
Because
cannot.
you're looking up
Oh,
you're looking up a signature, but if the leaf is
no,
defined
no,
but it's
no,
a
no,
module, that's
no, yeah.
also an error. Yeah.
No, makes sense, makes sense. Okay, so now let's use this up there because that's what we were doing this for. So in here, exactly on 377, we should. Ah, no, we are already ignoring
That
the
builds
thing.
actually.
Yeah, no, that's great. But now we need to handle the things in 380, right? That's the problem. The find OPT is wrong.
Yeah, it
So
is.
okay, we should lookup.signature. We have to change the compiler because we have to upgrade, not overwrite its modules to use the accumulators modules.
This is actually, yeah, this is,
Now go have dinner, be right back.
Sure.
okay. But this is a bat map of signatures. That means this is in fact, um, this is in fact not a compiler.
What? ACC is a
Yeah, so we
compiler.
can, it isn't.
Ah, it's not a full compiler. It's only the environment. Ah,
Oh, it's
fuck.
only, it's not even a proper environment, it's a signature.
But can't we just freak the current compiler and upgrade the env to be ACC for this?
That doesn't work because the types don't match.
What? I'm confused. I'm extremely confused right now. Let me repeat.
Look, you have...
What's the type of ACC? It's compiled module, right?
No, it's compiled signature.
Ah. Okay. Then I was crazy.
Yeah, it's
Okay,
at the
but
bottom here.
yeah, but doesn't this mean that we can just... Okay, can you go up to remind me what is using compiled signature? Yeah, here. Can we... Okay, I see the problem. Because we have to transform it to a plain signature in 36, and then upgrade it to a comp time, and then upgrade it to a compiled module, and then override the
No, no,
compiler.
no. This is not an upgrade. This is a side grade, actually.
It is a
That's the
side
problem.
grade. No, it is a side grade, you're right. Okay, so what's the plan? Are we fucked?
What's the plan? The plan is we probably need another lookup specifically for doing lookups inside of
What about trying to make the
signatures,
lookup
actually.
the lookup buckets generic? Because right now we are just sending a compiler. Can we make it generic somehow?
Can we make it generic?
Yeah, instead of receiving a compiler, we receive something that can be described by both the module key, the compilation of a module, and the compilation of a signature simultaneously.
mm, I mean,
Like
let
a
me think for a
parametric
second. Can
batmap
we?
string.
Parametric batmap string? No, because a compiler is not just a batmap string. It also has a parent.
No, but then the parent becomes a separate argument of the function. Doesn't really matter that. Because if you scroll down, I think we are extracting only two things out of the compiler, which is env and parent. The question is if the env is doable to make it generic, because the parent is going to become a separate argument in its entirety.
The problem is that the parent needs to be essentially, well, it needs to be isomorphic to a linked list of environments.
A linked list of environments.
Well, the pair env and parent needs to be, well, it needs to be isomorphic to a cons, and the parent can be, well, it can either have another link or it can be nothing, right? Because it's an optional.
But the parent is another compiler, man.
I mean, we can strip the compiler stuff and just look at the environment. The problem is this needs to be a... We would need to do a conversion, like turn this into an actual list or something.
Yeah, but that sounds expensive. Let me think a little bit. Scoping so hard. Well, I wouldn't say well, it's hard, but not because of complexity. It's because of there's too
Well,
much
it's
stuff.
hard. It's hard because we have two kinds of namespaces, right?
I wouldn't say that's the reason. I would say it's because there's a lot of things to pay attention to. Yeah, it is because of moving parts. There's so many things to pay attention. Okay, what's your proposal?
What's my proposal? My proposal would be. Um, Actually, let me stare at the code for a second. Right, this should. Let me just. Nested 2, nested 3. Alright, this should be. Other uses nested. Okay. Those things are terrible, by the way.
What? The names?
These names are terrible, yeah.
Well, it's fine. I had worse.
Okay, so this should work because this is a signature. So it's declaring that a module called users nested must exist, and it must satisfy this signature,
Yeah.
which must exist in the nested2 module.
Yeah.
So this would be an abstract signature, and
Uh-huh.
this would also be an abstract signature.
Uh-huh.
Uh, yeah, no, we totally should be able to do this lookup. The problem is that the types don't line up at all.
No, no, but that was the original problem, man. It's that because we made the signature assuming a full compiler, and in the case of the ACC on the left, we don't have a full compiler, and lifting that to a full compiler is kind of nonsensical.
We need to make another. I think we're not gonna be able to get away with not making another lookup function.
No, but then all the effort to stop in the middle with the polymorphic variants were all the effort was for nothing.
Uh, Not really. We can still reuse some of these tags. The problem is, okay, can we somehow reuse some of these at
What
least?
is the type of mod sig env? Because that's a type alias. What's the type? What's the real type of that?
Mod sig env. Which one? Oh, this one.
Yeah. A map of comp time.
It's the same type as the environment, basically, which is a comp time map.
You know what I
You know,
want?
we
You know what I'm
actually.
starting to want? I'm kind of
Mm,
starting to want to make 196 be parametric. Instead of being comp time, we just return an A.
look up mod sig. Instead of being comp time, we return an A.
Yeah. And then the env also needs to have an A there. Is that a
And
problem?
then the env also needs to have an A. It may not be actually. Mod sig env. Okay. This is this, which is the same as. Which is the same as. Which is in fact the same as this when comp time entity is instantiated to comp time. Which has exactly. Hmm. Yeah, I think if we make that polymorphic, we can probably get away with it, actually.
Yeah, but I'm a little bit
Let me
worried
think.
though. Because lines 201 and 207 are not generic. We're kind of relying on the fact that we know what it is. That's a problem.
Hmm.
But that's the only part that matters. Maybe we can pass a lambda there as an argument. Because everything else is kind of generic. The only problem is those two branches.
Yeah, we probably should be able to do something like that, actually. Let me think for a second. If we. Okay, what would be the parameters? They would have to be all of the free variables from this body. So what are they? Um,
Value for no, yeah, value for sure.
Value is one of them.
Qualifier, more,
Qualifier and more are defined up here. Yeah.
and that's it.
That is it, actually. Okay, so we can probably get away with something like
Ah, wait. 208 is a recursive call. Well, 206 no.
2, 206 is a recursive. That's not a problem because we have access to.
Yeah, I was thinking about passing this entire match of 200 as a lambda. But now,
Yeah, no, this would be part of the lambda body. That's not a problem.
but how do we call whoever is using us?
Like lookup mod sig would no longer be part of this. Actually, would it? Oh, it's because lookup mod sig qualified is here. Is that a
Yeah.
problem, actually?
Ah, no, you're right. No. Yeah, no. Yeah, that's the problem that I was talking about. That lookup mod C qualified on 206. If we have this in a lambda, how do we call our caller?
Well, we're going to receive the lambda up here, right? In lookup mod sig, this as one parameter up here.
Yeah.
That means it will be visible in here, no?
Um. Yeah, but that means that the lambda needs to accept another argument, right?
Which argument?
Well, the
The
callback in
lookup
this
mod
case.
sig?
Yeah.
Yes, it does.
That sounds jank now. Because there's at least one, two,
I.
three, four arguments for this lambda.
Is it 4 arguments? What if we parameterize this entire thing?
Huh? Yeah, what if you parameterize the entire thing? Which thing? Well, you mean lookup mod C qualified?
Yeah. Because fundamentally, we need to treat the qualifiers differently depending on if we're looking at where if we're compiling a signature or compiling a module, right?
Yeah, but the module case is the same for both, right? Like we want to parameterize this because we want to be able to change something about it. And we want to change the signature. The module is the same. That's why, like,
Hmm.
I'm starting to think this is an we cannot win in this situation. This is gonna suck regardless. It needs to have some copy pasting. I hate that, but I don't see another option. The lambda I think it's gonna suck.
It takes a rest and a value, rest value, and this is just parametric on the rest. Are we using parent env or names anywhere here?
Parent, no. Env, no. No, yes, actually, in the callback.
In the callback, you mean here?
Yeah.
But this is shadowing, this is not the same env that's up there.
Oh, so okay, I didn't see that. My bad. Okay, actually, so I think both are not being used.
Okay, so if we're not using any of these inside of here, these will need to be inside of lookup mod sig, right?
Um, sure. It doesn't need to, but we did it because it's well. This is a function that is only useful in this context. That's why we did it.
Okay, let me copy this here, just for the sake of having it easy at hand. But let's call this current,
Man, I love like okay, just side
and
note.
let's.
I love this type of situations that even though it sucks, it forces me to think on how I'm gonna solve an actual problem. Like because we are making a real thing, and the real thing generated a real problem, and that's so fun. It hurts, but it's fun.
Okay, so in our case, this wouldn't actually be a comp time. This would be like the case that we need to handle, right? This, let's call this,
This is the signature
yeah,
case.
let's just current, let's call this new, and then the type here is, instead of comp time, this is signature, right?
Yeah, yeah, pretty much. And no, that's it. Actually, that's actually it.
Okay,
Thank you
so
very
OK
much.
value, this is all the same, right? But then this is calling find opt modules. Where is
Mo
modules coming from?
true 17.
All right, it's coming from here. But this is not a thing anymore. This needs to be a module signature.
Is my audio okay, Mari?
It is.
Oh, okay. It's because I felt that I don't know.
If this is a plain signature, and then there's also the case where this can be, there's an extra case because this can also be an
Abstract.
abstract signature.
It needs to be have the content and the lock and all the bullshit. That's not gonna type check. Which, if we had pattern synonyms, would not be a problem. But we don't.
Uh, Plain signature, signature. But this is actually not a signature, is it? This is a compiled signature. Do we need to do the matching on this level?
Only if it
I don't think
matters.
we I don't think we do actually. So in fact, we can. I wonder, does this work?
Oh, do it nesting? I think it does.
And then we can get rid of this. Okay, that actually works, in fact.
That's awesome. That's actually awesome.
Okay, so what does these things have in common and what is different?
The module is the same shit, and the plain signature, yeah, it's also the same shit. It's aside from the matches on the 226 and the 206, it's the same shit. Oh, 200 and 219 as well. Do you agree? It's the same.
Yes, if we can somehow just handle the problem of this recursive call here,
Oh
we
yeah, that's
could
social
just
logistics.
parameterize this. We could just parameterize this case because up here is all the same as well, right?
Yeah, it's the same thing. Well, having a callback as an argument is fine. Like, if it's only that, I'm okay with it.
Yeah, no, I think we should be able to get away with it. It's just figuring out the details of, okay, what should the callback actually be and what should be the function that receives the callback. I think,
But I have a question.
I think,
How are we gonna
okay,
do the parameterization of the tags? Do you know how to do that?
do I know how to do that? We don't need to because that will be part of the return type of the callback.
I don't follow. How are you gonna replace as a parameter lines 200 and 219? How are you gonna accommodate both? If the only difference is their tags.
200 and 219.
Yeah. The only difference is that one is a tag of module and the other is a tag of module signature. But they are from different types, all that stuff. How are you gonna do that?
Mm, I think if we
Ah, AI is saying to make the constructor a function, and then you can use it in a guard. Fuck that.
Does that actually work?
Of course, you can make a function, a lambda, and then instead of doing the pattern
Oh,
matching nicely as
you
this,
mean you mean using a predicate? Yeah, no, that's no, just no.
and that's another problem with this approach. We are also exploiting the fact that module signature and module can be deconstructed in the same way with a record with the same name of a field. They have a field called modules in there.
They don't have the same type though.
Isn't both of yeah, it's not the same type. It's just the same name, which is just another variable to
Mm,
this equation. Like this seems like a perfect case of a C macro, believe it or not.
nah, it's not a case for a macro.
No, a C
Okay,
macro.
so
You
we
can
basically
definitely fix this problem using a C macro, man. Go on.
need a function that takes the content and then classifies it as either the same type as the return type or a signature, which is possible in our case. And then, um, yeah, what if we do something like this? Something like this. Let's define the type first. So type selector is actually this takes a parameter, right? So
Yeah, 2 years ago somebody asked this question on Reddit in OCaml, and the first answer is just make a bunch of predicates.
okay, so nested lookup or unexpected signature with signature. Oops. And we need to say off, of course. Um, but actually, this needs to be a arrow this. Does that work? It doesn't. I don't know how to make a function type apparently.
Function type. I can help with that. How to make a function. Okay, wait a moment. It's like this. Uh, Wait, what do you want to do? Tell me.
This type needs to be a function that takes an A and returns this thing here.
Oh. Um, have you tried putting the keyword fun before the A?
Nope, this doesn't work.
Man, am I crazy?
Do I actually need to extract the type of the sum explicitly?
Wait a moment.
Type
No.
A.
It's just a
Yeah.
bunch of arrows, man. You're right. Ah, but you want it to be parametric. That may be the problem. Can you try the same thing but
Oh,
without the parentheses at the time on the second?
oh, actually, what if I do this and I put it here, but we don't want the parentheses? Yeah, no, that doesn't work.
Really? So it cannot be structured. It needs to have a name. Interesting.
That's kind of sad, actually.
No, but it does work. Let's see what AI says.
Okay, so we take the selector and then we have to call the selector with the value and then pattern match on the result. And then we can probably keep the types. Okay, let's try this out. Let's make a fourth copy of this. Let's call this poly because this is polymorphic now. So this is an A. And it takes an A selector. And we match select value. And then we need to match.
Yeah,
And
this
then
is
we need to
this is this is what
match.
I'm interested to see how we're gonna fix.
Let me look at this type. This is actually a batch map of the nested thing, not just a thing. Which means actually this type is not quite correct. It needs to be a batch map string t. Okay, so if we do nested lookup modules, this should work. But then we need to pass select here.
Ah,
And then this is an unexpected signature with signature.
you need the location though. You missed that part.
This is signature.lock, and we do need a location, yes.
Yeah, so the no, now it's 213 that's wrong. Ah no, that also works. You did signature dot lock. That definitely works. This expression has type. Wait, what?
Oh yeah, I need this as well, actually.
Damn.
This should work, right?
Well, you still need to do a conversion, right? You need to teach somewhere, someone how to map a signature to an unexpected signature and a module signature to nested lookup.
That's easy enough. Let me do that right now, actually, before we move on. So, just for reference, I'm gonna keep the type visible here, the new types. And I'm going to edit the code on the right-hand side. Um, okay, so it would be let comp time select, and this would have, let's just call it C. I can't really make a type signature for this entire thing, can I?
What do you mean?
Like, can I say this? This is comp time selector. Does this work?
Why not?
Okay, so match
No, 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 no,
C
wait, wait,
with
wait, 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 wait.
um,
No, no, yeah, actually that's,
I can do this, right? Function
yeah, you can, but here's the kicker. What's the name of this function?
comp time select.
Oh, this is a value because it's returning a selector. There's no arrows in there.
The selector is the arrow.
Ah, that was what your question was about. It's because this is a function type. Let's try. I never
Yeah.
tried it.
Okay, so we have basically to do this now. So let's just do it. This is nested
Nested.
lookup.
Yeah. You
Otherwise,
can. Holy fuck.
Ay, ay.
Awesome.
and then the other one is the
Signature,
signature select, which is going to be a signature selector,
which is module signature on
and
224.
which is going to do,
Module signature.
yeah, basically this and this.
That's it. Wow, you did it. It needs three parts, one generic body and two converters, but you did it. Nice.
Yeah, so I don't think we need this anymore, right? But
No, you don't. Yeah, the body of 275. Uh, yeah, actually 270, right? We're gonna nuke that internal version there. All of this is gonna die, right?
a lot of this is gonna die, yes. We're using the parent just here, right?
Yeah. Yeah, the function that we wrote is gonna go in 302. Ah, my bad.
It's gonna go into O2. Okay. Okay, so basically, yeah, we're gonna have to clean this up in a bit, but let's just, let's copy this for a second, because this is gonna be the new version. And lookup mod sig. These and these can go away for now, and this can go away. This is the new one,
Yeah,
which
so
we're
I
going
think
to
I
replace with
think
the
you
old
can
one in a
kill
bit.
306 all the way to 323. All of that will die, right? All of this.
We're going to replace this with the parameterized version of this lookup function, actually,
Yeah,
which is
which
up
does
here.
everything. Does the match on the rest, and then does the match on the value. So you can kill the other one on the copied version.
Actually, I'm going to edit this on the left and keep this here on the right, because it's already here.
Yeah.
Okay, so here,
Yeah.
we can replace this with this.
Yeah. Yeah. Then on
We don't need to call poly, but we do need to take an extra parameter here, which is this.
yeah. Um. Oh, but then that begs the yeah, that begs the question if you need it on the 308 then. We can just abuse the fact that this is a closure now.
We can abuse that. We can, yes. That means we don't need this
Yeah,
anymore.
yeah. And then yeah, this is the part that is actually important. So oh no, this is calling ourselves. So just pass selector on 333. Pass the select as the selector as the last argument.
Mm,
This is just missing one argument to be okay. It's the last one, by the way, in 334.
the problem is that parent doesn't match the type.
What? What do you mean? It does.
Oh, it does actually.
It does. Now we need to do something in 338, and that's it.
We don't actually.
We do because we need to plug the. Ah, I see what you're doing. You don't have to plug the selector because the selector is coming from somebody else.
Problem is that value is comp time because first dot content, not this actually env.
Yeah,
Env
this
is
is
force needs
pinning.
to be
Yeah,
comp time.
yeah. This needs to be parametric as well. This needs to be the same a as the a of the selector. So mod sig env should be parametric now.
Yeah, this needs to be.
Yeah, and then you put the same a as the selector there. This is gonna break all the clones of code of this, but you should just be able to comment those out.
The problem is that the parent is not quite right because the t here, the parent did, yeah, the parent here. Uh, we're going to use parent.env in the recursive, well, in the recursive call, and that pins the type again. So we need to fix that.
No, but at that point, is that really worth it though? Because here's the thing. If we want, my feeling, my intuition tells me that this generic type is bubbling up to more like umbrella types. The parent is a compiler already. So we're gonna bubble that up to the compiler?
Mm, we can't, but what we can do actually is.
I'm starting to think we have to, man.
No, 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 no. We don't have to, but because like, if we're doing a signature lookup, then okay, here's the question, and this kind of affects what we can
Ah,
and can't do.
no, but I think, wait, I'm gonna let you say first, because I think I know how to solve it.
Okay, here's a question. If we have a signature, let's just use this one because it's already there. If we have this and we say this needs to be a module, we need to have a module that is whatever, but it uses nested 2, nested 3.
Uh-huh.
This should work, right?
Yeah, it should.
That means that, yeah, we need to be able to do the lookup up here,
Yeah,
which is the parent of this scope.
yeah.
Which means actually we do need to bubble this up to the compiler.
Well, I had another idea. I don't know now that if it's. It sounds like it doesn't solve it now that you mentioned that. Oh, this needs to be generic all the way. Because here's the thing. Remember what you said before. We actually need a linked
Mm.
list of useful environments to be like popping and like, oh, let's go to the parent. Let's go to the parent. But we can construct this linked list beforehand, before calling lookup mod sig new. Right now, instead of doing that, we just pass the parent and we do the pop-up on 333. We could pre-process all the like lineage of this thing beforehand and then do something about that. You see what I'm saying?
Yeah.
Because I really don't think we should bubble this up to the compiler, man.
I think we have to.
You think we have to? We don't have a choice. That's interesting.
Hmm.
I'm really not sure of that, man. Why can't we just make the list like in the color of lookup mod sig new, you know? You know what I'm saying?
Make the list in.
Yeah, we have a compiler in the color of lookup mod sig new. We're gonna have a compiler, which has parents and grandparents and the whole lineage. Can't we just pre-process this list in the caller and like call it a day?
We can, and actually we can even make that efficient if we don't use a list, but we use a lazy list. Do we have that by default in OCaml somewhere?
Make your bet.
Like a string type or something?
Um, okay, before bringing the bad news, I'm gonna look on the lazy mod, to be fair. Wait a moment. I'm gonna also stop the recording for as well.